make it bigger. I have an error here of some sort. It's crossing the. It's too close to the well or something. I'm not sure, but you get the point. Okay.
Excuse me.
Yeah.
If metal one layer crosses a transistor or passes over the transistor, what can happen? That
A metal
maybe
two.
in terms of the color, maybe the colors get messed up, huh?
If a metal two is crossing here, uh, nothing happens. This is on a different layer.
Metal two color is
It's different, yeah. Each metal has a different
metal
color.
one passes over the transistor crosses, then what can happen? That the color, in terms of the color, how they look, how can we see?
It's just the color. What's um okay guys, get I don't have much time, so I have to finish before 11. Okay, so please what? Right, whenever there's a yeah, there's insulation whenever you don't have anything. Right, yeah. There's a gate oxide between the poly and the diffusion. Yeah. Yeah.
The program is just available in our lab, so we can take a copy. Or
You can download it. It's open source and free. I'm gonna post instructions on Moodle like today.
Yeah.
But you need to have Ubuntu 9.04. Any newer version will not work.
In newer version?
Any newer version will not work.
But we have it in the lab, right?
You have it in the lab, yeah.
We can remote access to it.
Yeah. You can remote access, but it will be slow.
I
Anyway.
have some exercises with Magic in right?
You have some what?
Exercises in
Yeah. Like you're gonna have a homework.
Okay.
A lot of homeworks.
Not homework.
Well, homework is the best way to exercise. Anyway, so you can see here I've connected the gate of the NMOS to the gate of the PMOS, right? Okay. I'm gonna draw the VDD line. So this is VDD. I'm gonna connect the drain to VDD. So these are now connected. If I draw the metal one all the way over here, it doesn't matter because where there's a metal one contact, they're assumed to be already metal one. Okay. So now what's left to do is to connect metal one here, metal one here, and this is the output. Oh wait, I made an error. The connection should be here. Okay. And this is my output. Right? Now I want to put my input, which is also metal 1. And I want to place a contact here to the poly. Right? So I'll just do that and place a poly contact. If it works, it worked. You can see it's too close. There's a distance between a metal 1 and another metal. So here the metal is too close to the contact, so I have to move this contact. I select it with S and I move it, and then over here I'm gonna put some poly. What's the error here? Oh, the contact should be 4x4. So I'll just move it again. Okay.
And it dragged the polysilicon underneath the contact as well?
Yeah.
So where is the contact? You made the contact. Yeah, the contact, the square, the contact between the metal and the poly.
Yes.
So, but there's no poly under within this square.
When you place a contact, it places poly and metal and the contact. It
Yeah.
places all three things.
Oh
Yeah.
What happens if we have like two transistors like too far away from each other and we want to connect the poly to each other? What would you recommend here?
You only use poly for short connections like this because it has high
How do we do it
resistance.
if we don't have short connection?
You connect it to metal 1 and you use the metal 1 to connect. Okay, guys, I don't have much time, so just let me finish without questions. What did I forget here? I forgot like a very important thing, right?
Yeah, exactly.
Okay, just ask Mazen about it later. I forgot to connect the body, right? So I always have to connect the body to ground in an NMOS and to VDD in a PMOS. So what I do is I place body contacts from the ground into the well. So in an NMOS I connect the ground to the P well. So what I have to do is I have to increase the P well up till here, and I need to make a contact, which is called where is it? Okay, it's called P substrate contact to connect the P well to the ground. So I place one here. It's too close to the boundary, so I'll just go ahead and move it. Okay. By the way, you have to place several, at least 3 contacts of body. So I'll do another one here and another one here. The substrate contact. Okay. Same thing with the POL. I'm gonna put some contacts here. I do the N substrate contact because it's an N well. I do one here and then one here and one here. You can see it's a little frustrating, but it works. Now I still have to label the pins, so to label the nets. So what I do is I make a cross. To make a cross, you just right click the rectangle here, you go to the command line, you write label VDD, and you put an exclamation point because it's a global net. Whenever it's a global net, you put an exclamation point. So you can see there's a VDD here, and I do the same thing for ground. As for my input and output, I do a straight line like this, and I put it across the end of the terminal, and I do label, let's call it out, and this, let's call it in. Oh, okay. Now I write it. You can just press right when you're in the layout window. I mean, press W. You'd have to write a file name, so let's call it my inverter. Okay, so now I want to extract it into a SPICE layout. First of all, I write extract. This will extract it into a magic format kind of netlist, which doesn't work in HSpice. So the next command is to convert from that format into HSpice, which is X2Spice. Okay.
What does
Extract? It extracts the layout into a netlist, meaning a schematic. But
What
it's ext to SPICE, mean convert from the magic format into SPICE. Okay, now I'm gonna quit, and I'm gonna check the SPICE output, and you can see I have 2 transistors, with PMOS connected
Sir,
to.
we have to have Seymour in 5 minutes. We need to get
I know,
him set
I'm
up.
almost done.
We
So
need to get him set up.
okay, I'm almost done. So yeah, you can see I have 2 transistors connected to VDD and ground, and yeah, I didn't have time to explain everything, but we can go over that maybe next week.